All right, our second approach to solving a quadratic equation is to use the square root property. So the square root property says that for any algebraic expression, if u squared equals d, then u is equal to the square root of d and negative square root of d. So what that means is, like, if you have x squared equaling 9, since 3 squared equals 9 and negative 3 squared also equals 9, both 3 and negative 3 satisfy the equation. So the square root property can be used for quadratic equations of the form x squared equals d, or if you have x minus a squared equals d. So either one of those forms you can use the square root property. Okay, so example number 4, a, 3x squared minus 15 equals 0. So first, how do I know I can use this method? Well, I don't have a x term, just an x squared and a constant. So that's my giveaway that I can use the square root property. So to use the square root property, you want to get x squared alone first. So add 15 to both sides, canceling, leaving 3x squared equals 15. And then get x squared alone by dividing by 3. And we get x squared equals 15 divided by 3 is 5. Square root property says if you have something squared equaling a number, then the non-square of your variable x will equal two things: the positive version of square root of 5 and a negative square root of 5. Okay, so we want to see if those simplify. Perfect squares, if you don't know perfect squares, you should get this list down somewhere, either in your head or on paper somewhere. So just a few perfect squares. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169. So if you're familiar with those, you'll have an easier time with this. So we want to see if our square root simplifies. So first, is it a perfect square? No, 5 is not a perfect square. And from there, you'd want to see, is this number divisible by a perfect square? And 5 is not divisible by a perfect square. So these two answers, the square root of 5 and negative square root of 5, are your two answers. Okay, so that's approximately 2.236 and negative 2.236. But we want to leave our answer in exact form like this, no decimals and no rounding. Example 4b, 9x squared plus 25 equals 0. Okay, so if I solve this for x, again, we can use this method because there's no x term. So we want to get x squared alone first. Subtract 25 on both sides, giving 9x squared equals negative 25. Then divide by 9. X squared equals negative 25 ninths. Okay, 9 does not divide into 25, and only factors of 9 are 3, and that does not divide into 25. Or use your calculator. You'll see this fraction does not simplify. Okay, and so our last step here, x squared equals negative 25 ninths. Square root property tells me then that x would equal the square root of negative 25 ninths and negative square root of negative 25 ninths. Okay, for simplifying, whenever you square root a fraction, you can split up the numerator and the denominator separately. Okay, so negative 25 ninths, you can look at the square root of negative 25 and 9 separately. Okay, square root of 9 is 3, and the square root of negative 25, well, square root of 25 is 5, and the square root of a negative always gives you an I. So 5i over 3. And the other one's identical, except it's got a minus sign out front, negative 5i over 3. So there are your two answers for example 4b. Example 4c, 2 parentheses x minus 2 squared minus 8 equals 4. Okay, the giveaway on this one that tells you you can use this method is we have all of our x's inside of this parentheses being squared. So first thing is to get the parentheses alone. We're going to add 8 to both sides. 2 parentheses x minus 2 squared equals 12. Divide by 2. X minus 2 squared equals 6. Okay, now that the squared is alone, if x minus 2 squared equals 6, then just x minus 2 will equal the square root of 6 and negative square root of 6. Okay, so see if that simplifies. 6 is not a perfect square, and the only factors of 6 are 2 and 3, so that does not simplify. And to finish the problem, what I'd suggest is splitting this up into two problems now. Say x minus 2 equals the square root of 6, and x minus 2 equals negative square root of 6. Okay, and also notice this negative is not under the square root, it's out front, so there should be no I with that. Okay, to finish this, we're going to add 2. That eliminates minus 2. And add 2. That eliminates minus 2. And so our two solutions, the order we'd normally write them in is the square root last, so 2 plus the square root of 6. Since this is a positive, we have a plus. And our second solution, positive 2 and a negative square root of 6. So 2 plus square root of 6 and 2 minus square root of 6 are these solutions to this problem.